In this lecture, we are going to understand how to secure our network communication. So, if you want to secure network communication, there are secure protocols like SSL, Secure Socket Layer. And if you are exposing your APIs using HTTP, we normally use HTTPS. HTTPS is nothing but a combination of HTTP protocol and SSL, Secure Socket Layer. Similarly, if you are transferring files using FTP, we use Secure FTP, SFTP. SFTP is nothing but a combination of FTP and SSL. So actually we need to understand how this SSL works and how this HTTPS works. Then I'll show you how to configure HTTPS. If you need to understand HTTPS, you need to understand about what are certificates, digital certificates, and especially what is difference between a signed certificate and unsigned certificates. Basically, you need to understand about what is signature. So in this lecture, we'll understand concepts behind certificates, signatures, encryption, decryption, and how HTTPS works. So in next lecture, we'll see how to actually configure Mule application to use HTTPS. And also we'll discuss about one-way SSL and two-way SSL. Okay. So if you already know these concepts, you can skip this video. Okay. So let's try to understand what is signature. But before that, let us try to understand different types of encryptions. I hope you know, but quickly I'll tell you. So let's assume that there are two applications, application A and application B. Application A wants to send some data to B, and since the data will be traveling over the network, whatever application A is sending, nobody should be able to understand the data. Only B should be able to understand what A is sending. So what we do? We do encryption. So in encryption, there are two types of encryptions. One is symmetric encryption and another is asymmetric encryption. If you are using symmetric encryption, we use same key to do encryption and decryption. But if you are using asymmetric encryption, we use a key pair, a private key. There will be two things, private key and public key. So if you encrypt the data using private key, it can be decrypted only by using a public key and vice versa, right? So now if A want to send data to B, how the encryption should be done? Let's assume that A is having its own keys called as private A, public A, and B is having private B and public B. So when A wants to send data to B, let's assume that A wants to send hello to B, a simple text. So this data should be encrypted by using which key? If I encrypt it using public key of B, it can be decrypted only by using private key of B. Nobody knows except B. So whenever we are doing encryption, we always encrypt the data using the other party's public key, right? Okay, now you understood about encryption. Let us try to understand about what is a signature and what is the purpose of a signature. Okay, so now my requirement is, let's assume that again there are two applications, application A and application B. A want to send simple data to B, hello. This is not confidential data. So even if somebody sees the data in middle, when the data is traveling over the network, it's okay. But some middleman should not be able to tamper the data. So I don't want my data to be tampered. Whatever A is sending, B should be receiving the same. If in some case, if there is an application C which is tampering the data, B should be able to identify that the data is tampered and reject such data. This is my requirement right now, right? So the idea is, let's assume that I want to send hello to B. Instead of sending only hello, I can use some digest algorithms and compute digest of the original data. Let's assume this digest is hello digest. Okay. Now I will encrypt this digest with private key of A. Okay. And then instead of sending only hello, I will send this whole data to B. Let's take two scenarios, a happy scenario and an unhappy scenario. In happy scenario, let's assume that data is not tampered and data reached B. How can B verify that data is not tampered? From whom is B expecting data? A. So what B will do is, B will decrypt this part with public key of A. So it will get hello digest. Okay. Then now the original data, whatever it got is hello. Again B also will compute digest of the data using same algorithm. It will get hello digest. So both are matching. So data is not tampered. Let us go with a negative scenario. Somebody came in the network, in between, some other application C in the network is trying to tamper the data. So let's assume over the network, when A is sending to B, application C has intercepted it and it is trying to change the data. Instead of hello, let's assume it changed to bolo. Okay, so it tampered the data from hello to bolo. Then it has to compute a digest. So it will compute digest and it will become bolo digest. Okay. Now the digest has to be encrypted. Does C know the private key of A? No. What all it can do is, it can encrypt using private key of C. Now this data is tampered. Application C tampered the data and the tampered data is coming to B. But B is expecting data from A. So what it will do is, it will try to decrypt this part with public key of A. Will it be decrypted properly? No, it will get some junk value. Then it will compute digest of the actual data whatever it received. It will be bolo digest. Both are not matching, right? So data is tampered. So application B will be able to identify that data is tampered and it will be able to reject that data, right? So in this case, this encrypted digest, we call it as signature. So this encrypted digest is nothing but signature. Signature of whom? Whose private key is it? A. So this encrypted digest is nothing but signature of A, because private key of A is used for encrypting, right? So can I say that signature will change based on the data? Yes. If data is hello, then hello digest, and then we encrypt it using private key, right? So signature changes with data. So I can say that in this case, application A is signing the data and sending the signed data to B. And I can say that B is verifying the signature. Okay. To verify the signature, what B should know? B should know the public key of the other party. So in this case, public key of A. So if my application has public key, it will be able to verify the signatures, right? So normally signature is used to ensure data is not tampered, or we say technically signature is for assuring data integrity. Whatever data is sent by A is received by B. If in case data is tampered, B will be able to verify and reject it. So now you understood what is signature, right? Okay. Now let us try to understand what is a certificate, and then we will see what is a signed certificate. Okay, what is a certificate? Certificate is nothing but a document which contains the information about organization or a person, etc. So I'll just show you a simple certificate which I have. Okay, this is a certificate which I have. You can see the certificate information. Certificate is nothing but a document. It contains the details. Like this certificate is issued to whom? Server, and issued by somebody called as middle. And you can see here in this tab the details of the certificate. What is the signature algorithm used? Who is the issuer? What is the validity of the certificate? Who is the subject of the certificate, etc. So basically I would say certificate is nothing but a document which contains the information. Like my certificate will contain my name and all other details, right? Now suppose if I have my certificate and I give my certificate to somebody else, how do they verify that this certificate is not a fake certificate? Somehow we have to identify that this data, whatever is present in certificate, is true. Suppose if I have a certificate for my website, and if my website claims that it is Google, it's fake certificate, right? So how to verify? If somebody gets a certificate, how to verify whether certificate is a valid certificate or not, right? So certificate is a document, I said. It contains some data, right? Now what we can do is we can compute digest of data, whatever is present in the certificate, and if this digest can be encrypted by using a private key of a certifying authority. So there are a lot of certifying authorities. What we have to do is we have to get my certificate signed by a certifying authority. What do I mean by my certificate should be signed by certifying authority? If suppose my certificate contains some data, right? What the CA will do to sign my certificate? The CA will compute digest of my data present in certificate and encrypt this digest with private key of the CA. Now this whole document is nothing but my signed certificate. If this certificate, signed certificate, is given to other party, they will identify that okay, this signed certificate is signed by whom? This particular CA. So the other party, if they have public key of CA, certifying authority, what they will be able to do? They will be able to decrypt this part. They will get the digest. Okay. Then the other application can actually again compute digest of the original data. It will get same digest. Both are matching. That means whatever document this application got, it is not tampered. And this was verified by using whose public key? Public key of a CA. CA is a trusted authority. So since this got verified by using a public key of a CA, that means this document is signed by a CA, certifying authority. That means whatever data present here, is valid. That means if this data says that my name is Shiva, yes, the data is correct. The data has been verified by a certifying authority, and then only they have signed, right? So whatever data it is claiming is correct, right? So that's how my application will be able to understand whether the data present in certificate is correct or not. So now once you understand about signed certificate and certificate, Let us try to conceptually understand about how HTTPS works. So how HTTPS works? Let's assume that this is a server application which is exposing some resources using HTTPS, and this is a client application which is making a call. Now, when client and server are exchanging data, the data should be exchanged securely. This is my requirement. Even if somebody sees the data, they should not be able to understand it. This is my requirement. So if client makes a HTTPS call to the server, right? This server should be configured and told about where is the certificate. I'll tell you the configuration, how to configure the server. So assuming that server knows where is the certificate, right? Whenever a client makes a HTTPS request, server will respond initially with its certificate, right? Now, the client should be configured with something called as the trust store. You can assume trust store is a location where we keep trusted certificates. Trust store. So client made a HTTPS request, server responded with its certificate. Now client will check, hey, do I have this certificate in my trust store? All the trusted certificates will be actually kept in trust store. If yes, okay, client is trusting this server. Now, certificate is a document and it contains public key also. Remember, certificate contains some personal data about whoever it is, and also it contains a public certificate. Certificate contains a public key, okay. So now my client got the public key of server. So it got the public key of server. Now what the client will do is, client will generate a unique key, some random key. We call it as a session key. So client will generate a session key and encrypt it with public key of server, whatever it got. So when the server responded with certificate, in the certificate there will be public key, right? So the session key is encrypted with public key of server, and then client will send this data to server. Now server, it knows its private key, so it will decrypt this. Server also will get the same session key. So if client is sending this session key by encrypting with public key of server, if there is some third party application, can it decrypt this and get the value of the session key? No, right? For decrypting this, it requires private key of a server, so it is not possible. So this will be decrypted by only the server. So now server knows the session key, client knows the session key. From now onwards, whenever client is sending the data will be encrypted using the session key throughout this HTTPS session. Whenever server is sending, it will use the same key to encrypt and decrypt. So basically now whatever data client is sending, it will encrypt with session key, and whatever data server is sending, it will encrypt with same key. Decryption also is done using same key. So that means the data exchange is done using same key. So that means the exchange of data using symmetric encryption, right? So since the data is encrypted and sent over the network, it is secure, right? And do you think HTTPS uses asymmetric encryption or symmetric encryption? Actually, during the startup of HTTPS, the client and server exchanged some data, right? Initially, when client has sent HTTPS request, server responded with certificate. From the certificate, client extracted the public key and then it generated some session key, then sent the data to server. Server decrypted by using private key and it got. So here in this case, client and server are doing something called as a handshake. We call it as SSL handshake. So in this handshake process, the client and server are exchanging a key, right? The key is actually encrypted using public key of the server and it gets decrypted using private key of server, right? So this, when doing SSL handshake, it is using asymmetric encryption. But after the key is negotiated between the client and the server, same key is used by both the parties. That means the data exchange is done using symmetric encryption. That's how HTTPS is secure, right? Okay. Now to configure this, let me conclude this. Let's assume that I have server and I have client. Okay. So if I want to configure HTTPS between these two, if I want to configure the server to use HTTPS, I should have my server to store private keys, all these entries, right? So we use something called the key store. Key store is nothing but a document which contains information about private keys, public certificate and an alias. Actually in key store we can actually store lot of key value pairs, private key, public key. Actually in certificate public key will be there, right? So there won't be a separate public key, it will be stored inside a certificate. So in a key store we can have n number of entries. Every entry is identified by using an alias. Okay. So key store is a document which contains private key and public certificate along with alias information. There can be n number of such entries. Each entry is identified by using an alias. Now, one more thing also should be there. On the client side, there should be one more store called as trust store, where client will actually store only the trusted certificates. So again, here also we'll have alias, and also public certificate. That's all. So trust store should be there on client side and key store should be there on the server side. We have to configure this. So in Java, if we want to generate key store or trust store, we use a file with name extension .jks, Java key store. And there are a lot of other ways to store. One is pkcs and other things also are there. So right now I'll show you how to use JKS files for as a key store as well as a trust store, right? Okay. And in this case, if server is configured and told about where is its key store and what alias to use, whenever a client makes a HTTPS request, server will retrieve its public certificate from the key store by using the alias and then send the certificate. Once client gets the certificate from the server, client needs to check whether this certificate is there in the trust store or not, right? And then they will do the handshake, SSL handshake. In this case, only client is validating whether this certificate is a trusted certificate or not. But is server validating the client? No, right? So in this case, we are using one-way SSL. One way. That means client is only checking whether this certificate is a trusted certificate. Server is never asking client for its certificate. Server will just talk with any client in this case. But in some cases, you want server to validate whether the client is a known client or not. So in that case, let me show you clearly. In that case, let's say this is again a client application, server application. There will be two things. One is a server key store, and server also will have a trust store, server trust store. Client also will have a client key store where it stores the keys of a client, and client trust store. So if I want to configure client and server to use two-way SSL, we need to configure and tell the client where are the key store, trust store, server also with key store, trust store. Now what happens? Whenever a client makes a HTTPS call, server has to give its certificate, right? Server will retrieve the certificate from the server key store and then return it. Now, once client gets a certificate, server certificate, it has to verify if the certificate is present in the client's store, right? Sorry, I missed it. Whenever client is requesting for HTTPS, server, what it will do? Server will first ask, hey, give me your certificate. Okay. So again, let me draw it. Client makes a HTTPS request. Now in this case, first server will ask, hey, give me your certificate. Now client will look in its key store and give the certificate. Server will validate whether the certificate is there in my trust store or not. If it is there, then server will respond with its certificate. Then client will check, do I have server certificate in my trust store? Yes. If both ways authentication is done, then now the client will generate a unique session key, encrypt it with public key of server, send it. Right? So in this case, both client and server are validating the certificate. So this is two-way SSL. So in my next video, in my next lecture, I'll show you how to configure both one-way SSL and two-way SSL in Mule. See you in next lecture.